Okay, so ito, pinatay ko lang yung floor kanina. So, yan. So, requirement, yun nga, flow direction yan. Pinatay ko lang floor kasi kanina. So, requirements, strong fixed point and good guides are required. Large movements require utilization of several axial expansion joints. Baka doble, okay lang. Many fixed point and guides are needed for long 5 sections. Higher cost for fixed points and guides. Lateral expansion joint naman. Lateral expansion joint are used to absorb lateral deflection. Lateral expansion joint can move in all lateral direction simultaneously for absorbing expansion from 2 pipe sections in different direction. The lateral expansion joint is normally equipped with fixtures such as external tie rods. Kita nyo dito. Yung pagkaiba niya na, Emma. Ayan. Kita nyo axial movement. Ito lang. Next is, ito naman lateral. So, meron siyang external tie rod which allow the unit to absorb movements in all lateral direction but also to absorb the pressure thrust, including pull back tube. So the lateral expansion joints are available with 1 or 2 bellows, universal type, as well as with a number of end connectors like welding ends, flanges, and or combination thereof. Additionally, it can be equipped with other accessories like inner sleeve, covers, intermediate pipe, and tie rod. Intermediate pipe, kung minsan dalawa yan, may pipe pa dito. Tulo naman. So the type of expansion joint selected depends on both its cost effectiveness and its suitability for the function to be fulfilled. The economic considerations should not only take into account the cost of the expansion joint, but also the required fixed points, guide, and structures. Okay? Hindi na natin ipakita sa drawing yung mga yan. So, imagine niyo lang. Or search na lang sa internet. Ang daming references, di ba? Huwag lang yung ano-anong pinapanood. Pero pagdating dito sa mga kailangan nyo sa future, pinapabayaan na. Okay? Nakikita lang pagdating sa exam yun. Diba? So, applications, as lateral expansion joints absorb movements in lateral direction in one or more planes and absorb adjusting forces, they are widely used in more complex pipe systems with many lateral different direction and levels. Lateral expansion joints make possible the absorption of movements which are perpendicular to the longitudinal direction of the pipeline, which are perpendicular to the longitudinal direction of the pipeline and are therefore ideal for installation in pipe system with bends. C-shaped pipe system and three-hand system. Metal, makita nyo yan. Lateral expansion joint can be used as a tank settlement bellows, vibration absorber, and an all pipe system with bends or chains in the pipe direction. Lateral movements is a sideway lateral displacement of the ends of the expansion joint in a direction perpendicular to its longitudinal axis. Lateral movement can be absorbed both in the horizontal and the vertical axis direction according to the design of the pipe system. Lateral movement can to a limited degree be absorbed by one bellow. If larger movements are to be absorbed, we recommend a design with a universal expansion joint which contains 2 bellows with an intermediate pipe, absorbing the movement, and this also results in lower offset forces. In definition, so lateral movement as shown is delta y. So the parallel displacement is indicated as negative and positive. Advantages: absorb movements in all the lateral direction, absorption of large lateral movement with only one lateral expansion joint, and reduce load on all fixed point as the tie rod absorb the loads without transferring pressure thrust on the fixed points. Nakakatulong yun. Requirements: for absorption of large expansion, several lateral expansion joints are needed. So, magto-total ka na lang. So many fixed points in guides are needed for long pipe section. Yan lang. So pag nagdadag ka ng pipe, dagdag ka ng guide. So angular expansion joints allow. So next is the angular expansion joints. Ito naman itsura niya. Diba? Angular expansion joint allow angular moments only, contrary to axial expansion joints which elongate and compress in the pipeline axis. The angular expansion joint moves in an angular rotation in one or several planes controlled by a pair of hinges or a gimbal, later gimbal type. The angular expansion joint is as a standard delivered with either hinges or gimbal and can be manufactured with any end connection such as welding ends, welded flanges or loose flanges or combinations thereof depending on client requirement. Itong term na gimbal, later yan, makikita niyo dyan. Huwag mo na ngayon. So, hinge angular expansion joints. Hinge angular expansion joints are equipped with hinges to absorb angular moment rotation in one plane only. The hinges are designed to resist the pressure thrust from the pipe system. Single hinge expansion joints are generally used in pairs or three pairs with a connecting pipe system between and widely used in irregular and complex pipe system. So gimbal and angular expansion joint are designed to absorb angular moment in several planes without transferring pressure thrust onto the fixed point. A gimbal expansion joint is more flexible than a hinge expansion joint as the gimbal enables multiple angular rotation. Dito. Yan. So ito, yan lang. So ito gimbal, si marami na din ba? Okay, nag-gimbal ka dyan. So, angular expansion joints in general. So ito yung, pag kita nyo, yan. Angular expansion joint offer a wide range of options and when built in 2 or 3 pin, ito yung pin niya, yan, nag-rotate siya. Yan. Ka-hinge yan, di ba? Pin system. T-pin system, ito naman is yung marami ng expansion joint. They can accommodate very large moment with a very low reaction process without the need for a fixed point and structure. As angular expansion joints are fully restrained, they require only inexpensive guide or intermediate guide. This gives an economic advantage in large diameter, hot piping system, even if the movements are complex and in several planes. Further, the hinges or gimbal can be designed to support the dead weight load from the adjacent pipes and connected equipment and to carry wind load. There is no load in any other external load from the pipe system, minimizing the need for fixed point in the structure. The hinge can also be designed to eliminate torsion forces acting on the bellows. The bellows does not allow any torsion, and this should be counteracted against in all cases. Okay? So, since mga background lang ito turo, so check nyo na lang yung ibang na-explain dyan. Marami namang references dyan. Yeah, pag dinahat natin yan dito, so, ang topic natin is simple, ito na lang. Ang sa course natin hindi na building design, kundi ito na lang ang topic na to. Okay? Huwag sa kasta. Sa inyo na yan. So, when the angular expansion joint are installed in two hinge or three-hinge system, the distance intermediate pipes between each unit should be as large as possible as this allow maximum lateral deflection of moment to be absorbed. If the thermal growth of the intermediate pipe is significant, a three-hinge system is required. So, angular moment definition is an angular rotational displacement of expansion joint where its longitudinal axis is displaced as an arc from its initial position. This is to be understood as an angulation of the expansion joints two end planes relative to each other, which results in the longitudinal center line becoming an arc, like a bent pipe bed. Explain yan kaya lang ayusin natin. Oh, ayan, ayos na. Next, the convolutions, this one, are uniformly compressed along the inside of the bellows longitudinal center line and uniformly elongated along the outer radius of the arc. Torsion or twisting of one end with respect to the other end about its longitudinal axis and is not to be understood as angular rotation. Definitions: angular moment is shown as delta theta and is stated in degrees. Angular rotation is indicated as negative and positive respectively. Advantages: absorbs angular moment in single or multi-plane, use of normal guides, reduce loss and all fixed point. Requirements and the changes in flow direction, pipe direction is required. More space consuming than axial expansion joint. Okay. 2 or 3 expansion joints are required for a system. Next, universal expansion joints. Ito nang pinamagit na 2 pipe o may intermediate pipe. Ito na itsura niya. Okay. Universal expansion joint consists of 2 multi-convoluted bellows connected with an intermediate pipe into one assembly. The universal expansion joint can be equipped with all kinds of end connections, like welding ends, welded or loose flanges, and an endless number of accessories such as inner sleeve, cover, and movement controls. Universal expansion joint featured in this catalog, so tanggal restricted to maximum design pressure of 2.5 bar gauge. But as customized solution, they can be designed for higher pressure. The universal expansion joints allow a large amount of lateral offset in multiple planes, and lateral deflection can be increased or decreased by changing the length of the intermediate pipe. So, expansion joint, universal expansion joint, natanggal so ano. Okay, wait natanggal. Okay. Universal expansion joint do not use tie rods and are therefore suitable for no pressure applications. Fixed points and guides must be sufficiently designed to withstand the full pressure task forces and other loads. So a universal expansion joint is not to be confused with a lateral expansion. Okay? Ito yung mga fixed point, yung fixed point nga, mga anchor, support. So meron tong tinatawag ng mga task forces na pupunta doon yung pag nag-expand, pupunta yung force niya doon, thermal force. Di ba? Sa strength niya yan, physics pa nga, pasok din. So yun. Itong guides, sa nagmo-move, meron sa doon is yung flexion. The application, so a universal joint pala is not to be confused with lateral expansion joint. So application, universal expansion joint can absorb movement in all directions and are used in uncritical low pressure installation like ventilation duct, exhaust gases, fresh air ventilation, and process equipment. Advantages. Application. Definitions. Movements is shown in delta X, delta Y, and so yung mga pinakita natin delta X, delta Y, delta theta. So the parallel displacement is indicated as negative and positive, respectively. It is very important to notice if the moment is stated in combination universal or as an alternatively combination of different directions. So advantages: absorb movements in all directions, and absorption of large axial movement and lateral movements in one expansion joint, and can be modified to suit existing installation gap. Requirements only for low pressure installation. Fixed points in good guides are required. Many fixed points in guides are needed for long pipe section. Pangit yung di nakabul. Next is the exhaust expansion joints. So, nakita yun sa mga genset, di ba? Yan. Exhaust expansion joints are designed to absorb heat-induced expansion and contraction of pipe system and exhaust system. It is developed as a wide range of exhaust expansion joints which are designed to give high moment absorption with low spring rate for best overall performance. The physical pressure rating for exhaust expansion joint temperature depending is 1 bar gauge. Gauge. These units are available with many end fittings options, including welding ends, flanges, welded and loose. For smaller sizes, it is often possible to slide the bellows tangent over the exhaust pipe and secure using band clamp or worn live tips. Exhaust expansion joints can absorb axial and lateral movement alone or in combination, and it is usually the required movement capacity which determines the selected configuration. A single bellow is normally selected to accept mainly axial movement, although some lateral movement is usually possible. Where the amount of axial movement is outside of the capacity of a single bellow, a double expansion joint may be necessary. When the unit is required to accept significant amount of lateral movement, including application where axial movement is applied simultaneously, a double bellow is usually the preferred option. A double bellow unit has an intermediate pipe between the bellows, and sometimes this is an integral part of the bellows tube, reducing the needed for welding joints. Exhaust expansion joints are designed to be as light as practically possible to give minimum loads on hanger and pipe supports. Further, the bellows technology often incorporates multi-layers, giving maximum movement and flexibility or minimum deflection forces in good fatigue properties with good performance in good conditions where vibration prevail. Then, exhaust expansion joints are generally unrestrained, so the pressure force generated by the bellow when pressurized together with the deflection forces resulting from movement must be contained by the system fixed point and guides. So wala siyang control dito yung mga rod. Diba? At high temperature or where the low velocity is high, always recommend an inner sleeve in the bellow. The inner sleeve protects the bellows against abrasion from any particular matter and the low, medium, and help to smooth the gas flow over the convolution, which help in the reduction of turbulence. It can also help to reduce the temperature of the bellows in the expansion joint. So, yan. Yan ang purpose ng inner sleeve. Ito, wala. Okay? Application. Exhaust expansion joints are used in a wide range of applications, including gas turbine exhaust, power units, generator sets, marine propulsion system, OEM, engines, and auxiliary system. Okay? OEM is original equipment manufacturer. Now, for advantages, it is a gas tight and resistant to corrosion and temperature, absorb vibration and oscillation, lightweight, reducing loads on hanger and pipe support, very low spring rate and high flexible performance reduces loads on hanger and pipe supports, economical. For the requirements, it has a high flow velocity, often requires an inner sleeve. Exhaust bellows exposed to vibration should be designed to ensure that the natural frequency and any harmonic do not coincide with the frequencies of the exhaust system. Yan. Alam nyo to, sa vibration engineering, tinawag niyan, resonance. Now, expansion joint materials. The selection of the bellow material is generally based on the following aspect: the formability or ductility, weldability, thermal stability and strength, corrosion resistance, corrosion properties such as process media, surrounding environment, internal cleaning agent. Then mechanical properties like high temperature service, cryogenic service, operating stresses. Manufacturing properties like forming and cold working capabilities, cost and material availability. Okay. Okay. In particular, aggressive conditions, particularly abrasive conditions, special materials with high corrosion resistance should be used. The resistance material should be at least equal to that of the adjoining pipe. So the demand for highly flexible expansion joint focuses on the use of multiply bellows. Yung maraming, multiply, yung maraming bellows, patong-patong, where very thin wall convolution prevent corrosion. Whenever in doubt, it is recommended to use a material with higher corrosion resistance for the bellow, at least for the inner ply. In many cases, nickel-based alloy like Inconel 600, Inconel 625, and Inconel 825 are suitable. Okay? So, first time kung hindi ko alam kung first time yung magkano ng Inconel, and Incoloy, so check nyo na lang yung engineering materials nyo. Okay? Expansion ito. The resistance table provided can be helpful in material selection. So ito. However, the choice of suitable corrosion resistant materials should be based on the experience of the user who is most familiar with the particular features of the system and the operating window. Ayan, temperature limits for Velos material. So this is a European code. European code yan. So check nyo lang kung ano yung equivalent niyan sa sa ASTM. Okay. So yan, steel name, minimum maximum. Ayan, nickel alloy. Heretic steel. Ayan. Yung mga equivalent to sa ASTM. Okay. So, ito. So, for pressurized application, according to EN 14917, the temperature range can be seen from the previous page. For lower pressure application and or other design code, higher other temperature ranges apply. So, ito na yan. Stainless steel, type 300 austenitic series. So, ang ano niya is 1.4001 AN 10028/7. So, European norm, AN. So, AISI 1T04 naman sa ASTM. This is ASTM 840-04. Ito lang mabanggit ito. So, services, itong stainless steel type 300. Ito naman yung TO4 services, a wide range of application. It consists organic chemicals, dyes, and a wide range of inorganic chemicals. The alloy resists nitric and sulfuric acid at moderate temperature and concentration. It is used extensively in piping system conveying petroleum product, compressed air system, steam, flue gases, and liquefied gases at cryogenic temperature. Next is the TO4L. This alloy is an extra low carbon variation of 1.4001. Ito or TO4. Ito nga may L. With 0.03% maximum carbon content that eliminates chromium carbide precipitation from the welding process. As a result, this alloy can be used in more severe corrosive environments than alloy ito or TO4, stainless TO4. It is prepared over 1.4001 for nitric acid service. 1.301 yun nga yung ASTM TO4 o AISI. SSTO4. Now is the TO6. 1.4401. This alloy has a higher nickel content than 1.4001 of TO4. The addition of 2 to 3% molybdenum gives it improved corrosion resistance when compared to TO4, especially in fluoride environments that tend to cause pitting. So, mas mahal to, di ba? Mas mahal to kaysa sa binary stainless TO4. Typical applications are flue gas duct, marine service, crude oil service, heat exchangers, and other applications in the chemical and petrochemical industries. So, low carbon naman, ito, with 0.03% maximum carbon. It is commonly used for highly corrosive application where intergranular corrosion is hazard. So, parang ano tayo, nasa engineering materials, di ba? So, 1.4571 or T160i. With the addition, stabilizing of titanium and molybdenum, this alloy shows very good resistance against carbide precipitation and intergranular corrosion. So the main advantage of 1.4501, so T160i, is that it can be held at higher temperature for a longer time without sensitizing. So precipitation occurring. Typical applications areas are chemical and petrochemical industries, paper industry, food processing, and heat exchanger. Next is the AISI 321. So the addition of titanium to this stainless steel acts as a carbide stabilizing element that provides carbide precipitation when the material is heated and cooled to the temperature range between 430 to 900 C. The alloy finds usage in many of the same applications as TO4, where the added safeguard from the intergranular corrosion is desired. Okay, this is 1.4501. So next is the heat resistant steel. So ito yung mga heat resistant steel. So, andito yung mga ASTM, saka yung mga ibang code. So, paste natin dito sa numbering. So, ORAN, 1.4828 is high temperature steel are designed to be used at temperatures above 550 C. In the temperature range where creep strength are the dimensioning factors and high temperature corrosion occur. Optimizing steels for high temperature has meant that their resistance to aqueous corrosion has been limited. All steels are austenitic, resulting in relatively high creep strength values. Standardized high temperature steels for service at temperatures up to 1000 C in high air. Utilization in the temperature range 600 to 900 C can lead to embrittlement of the material. Next is the high alloyed steel, 2.4816 or EN10095-1 or Inconel 600 so ASTMB 168-600 or UNSN 06600. Dami ah. The nickel chromium alloy offers high strength over a wide range of temperature together with good resistance to a variety of corrosive environment. It finds wide use in steam in saltwater services where it is virtually immune to chloride stress corrosion. Okay. Then 2.4856 EN10088-1 or Inconel 625 or ESTM B440-625 or UNS N06625. This alloy comes with higher chromium content than alloy 600 together with the addition of 9% molybdenum. This results in superior mechanical strength and corrosion resistance over a wider range of temperature and corrosion resistance. It is used in many critical applications such as heat exchanger and FCCU. Yun pala, fluid catalytic cracking unit. When exposed to temperatures above 500 C for a prolonged period, the alloy may become brittle. Similar to Inconel 625 and Inconel 625 LCF, it has the same mechanical strength and corrosion resistant properties, but with a slight difference in material composition and size, can enhance low cycle fatigue properties at elevated temperatures. Take note itong nickel chromium, natandaan nyo yung tawag na nickel wire. So, ginagamit yun as a heat element sa kantsa. May mga sa ano, ginagamit yun. Kung ang temperature mo is mga 500 C lang, pag mataas dyan, so meron naman tinatawag na aluminum chromium. That is for mas mataas ang temperature na. Yun ang ginagamit ngayon. Okay. For low temperature, you can use nickel wire for heating. So next is 1.7846 Incolloy 800 tayo. This is less expensive than above mentioned nickel alloys due to lower content of nickel. Good properties against oxidation, carbonization, and other high temperature corrosion as well as mechanical strength at high temperature. Next is the 1.4958 EN10088-1 then and Incolloy 800S UNS N08810. So in situations where a greater resistance to stress of rupture and creep is required, Incolloy 800H is used instead of Incolloy 800, especially at elevated temperatures higher than 816 C. Furthermore, Incolloy 800H has a relatively good resistance to chloride stress corrosion cracking. Next is 2.4858 or EN10088-1, so Incolloy 825. ESTMB 424 05 or UNS N08825. So this copper chromium nickel alloy exhibit excellent corrosion resistance to the most aggressive acid and particularly against hot concentrated sulfuric acid and in sulfur-bearing environment. Due to its content of nickel in conjunction with molybdenum and chromium, the Incolloy 825 offers excellent resistance to reducing environment, such as those containing sulfuric and phosphoric acid. It supports resistance to local corrosion like freebies and fitting and offers resistance to a variety of oxidizing substances such as nitric acid, nitrates, and oxidizing salt. And the resistance of alloy 825 makes it the preferred choice for various applications such as chemical processing, pollution control, oil and gas recovery, acid production, pickling operation, nuclear fuel processing, and the handling of radioactive waste. Yeah. So 2.4605 or EN 100XX+1, alloy 59. ASTM B575 or UNS N06059. Alloy 59 is a nickel chromium molybdenum alloy with an extra low carbon and silicon content. The alloy has a very good resistance and high mechanical strength. It is characterized by excellent resistance to trains to a range of corrosive media in oxidizing and reducing condition, plus resistance to pitting and crevice corrosion. The alloy has outstanding resistance to acid like nitric, phosphoric, sulfuric, and hydrochloric acid, including sulfuric and hydrochloric acid mixtures. So, materials to. So, meron kayong engineering materials na siyempre background na ang tinuturo. So, dito is additional naman to. Hindi naman kayo materials engineer o yung metallurgical engineer na mapamilya, kakabisaduhin to. Okay? Sa dami ng mga standards. So, that is basic lang. Kung alam nyo na meron ganito na materials at saan ginagamit. Okay? Ngayon, kung gusto nyo malaman bakit ito ina-apply, bakit ito resistant sa may itong resistance sa corrosive media, so ibang course yun. Doon na kayo as a metallurgical engineer. Ang selection of joint. So the successful installation of expansion joint in a pipe system requires the careful consideration of many variables. So the most important issue is to establish the direction in which the movement are acting and in which way the movement should be absorbed. Once this information is known, the solution incorporating the most suitable expansion joint types can be determined. Complex pipe system must be subdivided into a number of less complex sections. So, divide mo to ensure the optimum movement absorption in several directions para makita mo kung saan mo papagalawin. Each section is usually divided by a fixed point between each section. Okay, so drawings. In the following pages, example of good practice in the use of expansion joint in different pipe system are illustrated. Sa mga next slide. The drawings are freely adapted from the applicable standard and are in accordance with the drawings available in the latest version of the standard prevailing at the time this catalog publication. Okay, so binasa nitong reference natin. So ito yung mga symbols niya. This is the FP, fixed point on the street pipe. FP, ito yung placed on the corner. Ito niya, yan, fixed point. Nakikita niyo na ba? Yan. Light fixed point. Yan. Ito naman is mga guide. Vertical, horizontal, GN, D1, D2, following guide 3. Yan, mga guide niya ng 5. Okay? So natin. Yan. Fixed point, nakita niyo parang pin. Parang di siya makagalaw. Pako. Sa pinako niya. So, fixed point guides, etc. Fixed point and guides for axial expansion joint. Nakita nyo dito, yan, tatlong fixed point, tapos ito yung mga guides. So, may measurement yan kung ano yung distansya mo. Ibig sabihin, must be less than or equal to 4 times diameter hanggang haba. Okay? So, ganun din. This is the 14 to 20 times the diameter. So, okay? Maka mag 20.1 times diameter. So, hindi recommended. Hindi bawal, kaya lang hindi recommended. It is important that fixed point is placed as close as to the axial joint as possible. Nandito. It is important to note that only axial expansion joint can be installed between two fixed points. The distance between the expansion joint and the first guide should be a maximum of 4 times diameter. So the distance between the following guides should be 14 to 20 diameter. So ito yung illustration. Follow the rules. Yan. Follow the rules. Huwag maging violators din. Ha? So kaya tayo may mga reference. Pag nag-anak kayo, huwag kayong lagay ng guide na hindi sumusunod sa rules. Dahil pag pumasok yung mga marunong na mga official, mga inspector, sisitahin yan. Papadagdagan yan o pagkulang. Okay? Pagkulang, papadagdagan ng inspector. Okay? Pag sobra, yung owner ang magbabawas niyan. O yung contractor na nagtitipid. So sila ang magpabawas niyan. Sa inspector, walang problema yun. Sobra eh. Above the minimum. Siyempre, yung sobra above the minimum, magastos naman. Siyempre, yung kliyente naman, tanggalin mo na yan. Hindi naman pala kailangan. Tama na pala yung tama na pala yung 3, ginawa mong 10. So, sabihin ng kliyente mo, tanggalin mo yan. 3 lang. Okay? Pero ginawa mong 2, yung inspector naman magsabi siya, dagdagan mo ng 1. Yan. Okay? Gets niya? So, yung mga interesado lang. So, axial. Straight. Sa axial, meron tayong straight piping section with an axial expansion joint. So this illustrates the importance in the use of 3 fixed points, as the use of 2 or more axial expansion joints in the piping system will create an undetermined arrangement. The amount of movement imposed on each expansion joint is not controlled, as the pipe between the 2 bellows can move sideways freely in both directions depending on the direction of the pipe and differences in stiffness between the bellows. It is always important to have 1 axial expansion joint between 2 fixed points. Ayan. Isa siya, tapos may 2 guide. Bakit 2 guide? Kasi pag nag-ano to, pwede itong mag-curve. So, meron siyang guide yan. Isa mag-curve. Okay? Next is the axial expansion joints not restraining the pressure truss. So, the piping should be divided into sections by means of fixed point, guides or restraining tie rods in order to have only 1 expansion joint per section of the straight pipe. The fixed point and other restraining devices should be designed for the full pressure thrust from the bellows effective area plus the bellows displacement force. Additionally, the forces generated by the friction within the guides should also be considered. Okay? Napakita ko lang yung figure, yung analysis is ibang theory na yan. Simple single axial expansion joint is located on the large diameter side of reducer. Ito naman yan. When on the same straight pipe section, an axial expansion joint is located beside a reducer. So, sabihin, bago lumiit. So, the loads on the small fixed point should take into account the full pressure thrust of the expansion joint and additionally, the possible offset of the pressure thrust if the reducer is eccentric. Ito yung mag-suffer. Next, straight piping with offset with axial expansion joint. Shows the application of a single expansion joint in a pipe system. It should be noted that application of this type is not usually recommended and will only perform satisfactorily under certain conditions. As shown in the pipe system, the pipe system is provided with fixed point at its end to absorb the pressure, movement, loading, and guide friction. Where the line contains an offset, this load must be first transmitted to the offset length, resulting in a movement on the pipe system. Where the pipe system size is small, the offset appreciable are where the pressure and movement forces are relatively high. This configuration may result in overstressing or distortion of the pipe system guide. Note the proximity of the expansion joint to a fixed point in the distance between the first guide E1. Further, the spacing between the first guide and the second guide G2 and the spacing of GN along the rest of the guide. Guide should be installed near both ends of the offset leg to minimize the effect of the bending moment of the system. Dapat malapit yan. Yung movement, yung bending niya, ito, dito. Pagdating doon, so magtutulak doon. So, dito ka maglalagay. Control mo siya. May distansya yan. So, straight piping with bent offset with axial expansion joint. Bent or offset. So, ito yan, mga banggit. TPPI is good practice in the use of single expansion joint to absorb axial pipe expansion. Note the use of one expansion joint between two fixed points. The distance between the expansion joint and the fixed point in the proximity of first guide. The spacing between the first guide and the second guide is the spacing of the guide GN along the remainder of the system. Next is the axial pipe system expansion in a pipe system with branch connection. Kita nyo sa picture. TPPI is good practice in the use of expansion joint to absorb axial expansion in a pipe system with the branch connection. The fixed point at the junction, which in this case is a T, is designed to absorb the thrust from the expansion joint in the branch line. Okay. Note the proximity of its expansion joint to a fixed point. The closeness of its first guide G1 and the spacing between first guide G1 and the second guide G2 and the spacing of guide Gn along the remainder of the H5 section. Ano pa na ba yung class nito? So, may tsura yun sa fluid mechanics, fluid dynamics pala. Yan, makukuha mo yung thrust niya. Yung weight. So, axial expansion joints in pipe system with reducer. So, TPPI is good practice in the use of expansion joints to absorb axial expansion in pipe system containing a reducer. The fixed point at the reducer is designed to absorb the difference in the expansion joint thrust on each side of the reducer. Note the proximity of each expansion joint to a fixed point. So again, the closeness of each first guide G1 and the spacing between the first guide and second guide G2 and the spacing of the guide GN along the rest of the pipe system. So nabi natin, di ba, yung spacing sa unang, ito. Ito rin yan. Yan. Okay, straight piping section with two bends and axial expansion joint. So naman, sabihin na ito yung bend. Sa 1, 2, dalawang bend. In cases where a universal expansion joint must absorb axial moment other than its own thermal load, it cannot function as a tight expansion joint. It must be used in combination with fixed point to absorb pressure loading. The relative expansion between two vessels results in both axial and lateral moment on the expansion joint. Both vessels must be designed to absorb the load on the fixed point. Control laws or pantographic linkages may be used to distribute the movement equally between the bellows and control the movement. Lateral. Ito naman mga application ng lateral expansion joint to absorb lateral movement. Ito. Shows a tied universal expansion joint used to absorb lateral deflection in a single plane Z. Then, where dimensionally feasible, the expansion joint should be designed to fulfill the entire offset leg so that its expansion is absorbed within the tie rod as axial movement. The tie rod should be extended to the elbow center line when particular. When practical. Okay. The thermal movement of the horizontal line is absorbed as lateral deflection by the expansion joint. Only directional guiding is required since the compressive loading on the pipe consists only the force necessary to deflect the expansion joint. So any thermal expansion of the offset leg external to the tie rod, such as that of the elbow at either end, must be absorbed by bending of the horizontal pipe lengths. Provision should be made in the design of the guides to allow for both this deflection and reduce the leg expansion in the bend position. Tie rods to prevent axial movement. So a piping configuration that permits the use of adapted tie rod to prevent axial movement frequently simplifies and reduces the cost of the installation. Due to the tie rod, the expansion joint is incapable of absorbing any axial movement. Okay. Thermal expansion other than its own thermal expansion. So the thermal expansion of the piping in the circle leg is, as a result, imposed as deflection in the longer piping leg. Where the longer piping leg is not sufficiently flexible and where the dimension of the shorter leg is suitable, tie rods may be installed spanning the entire short leg so that no deflection is imposed on the longer run the from its source. Okay, dito kasi ang ano niya, ang movement niya ganun lang. Okay? May binanggit dito, the expansion joint is incapable of absorbing any axial movement. So lateral lang ang movement niya. So except dun sa thermal expansion ng Thailand. Okay? So dito naman binanggit niya dito is para so walang deflection, isang deflection pa nag-expand yung temperature. So magkakaroon ng thermal expansion ng short pipe mo. So mapupunta dun sa magbebento to ditong longer pipe. So para hindi maano doon, iino mo yung babain mo tong Thailand. Diba? Spanning the entire short neck. Universal expansion joint in C bend. Universal naman to. Shows a typical application of tied universal expansion joint in a three-plane C bend. So yan, kita niya. Kaya lang, ito nakita ko rin. Since the universal expansion joint can absorb natural deflection in any direction, the two horizontal piping legs may lie at any angle in the horizontal plane. So, tinan yung figure. Next naman is ito. Lateral expansion joint, lateral naman with tie rod. The drawing shows the possible movement. So, the piping connected at the bottom should be guided in such a manner that the expansion joint is not subject to torsion. Lateral expansion joint with three or more tie rod. This kind of tie lateral expansion joint is used in similar way to that of two gimbal. The only difference is that the thermal expansion between the retaining rod are compensated with the expansion joint. Relevant compression or extension has to be included into the particular calculation of the value. Yeah. So lateral expansion joint with three or more tie rod. Bakit parehas? Parehas talaga. Okay, tama to. Para siya ng title. Lateral expansion joint with three or more tie rod. So the use of lateral expansion joint with hing tie rod in three-dimensional piping system. So this is ano naman to, hing tie rod. In cases be critical as rotation around the longitudinal axis of the expansion joint is theoretically possible. Rotation around the longitudinal axis of the bellows should be avoided. So ito, rotation na yan, avoid nyo yan. Next, single expansion joint for combined movements. As a single expansion joint is the least costly option, it is normally the first to be considered. This configuration shows a typical application of a single expansion joint absorbing combined axial movement in lateral deflection. The system closely resembles the arrangement shown for the axial movement in the preceding section. The expansion joint is located at one end of the long piping leg with fixed point at its end. The guides are well spaced for both movement control and protection of piping against buckling. The fixed point VF at the left of the end pipe system absorbs the load on the fixed point in the direction of the expansion joint axis, while also permitting the thermal expansion of the short piping leg to act upon the expansion joint as large lateral deflection. So due to the fixed point, loading exists only in the piping segment containing the expansion joint. Expansion joint installed in the short piping length. This configuration is an alternative arrangement in which the expansion joint is installed in the short piping leg and the principal expansion is absorbed as lateral deflection. The longer piping leg is free of compressive pressure loading and requires only fixed point and guide. Ito. Next, the hinge system. Dito tayo. So, hinges in a system. Hinge expansion joints can and sets of 2 or 3 be used for absorbing large lateral and axial movement. In general, there should be not more than 3 axial expansion joints installed between 2 fixed points, of which maximum of 2 gimbal can be of expansion joint sa mga hinge system. So, 2 hinge system. So, it illustrates the use of 2 hinge system to absorb the major thermal expansion in a single plane seabed, since the pressure thrust is absorbed by the hinges on the expansion joint. Only fixed points are required at each end of the piping system. The thermal expansion of the offset section containing the expansion joint must be absorbed by the bending of the piping legs perpendicular to that segment, since the expansion joints are restricted to pure angular rotation by their edges and cannot extend or compress. So the amount of bending deflection imposed on each of 2 long pipe legs may be controlled by the effective design of guides and support. Where one long leg is sufficiently flexible to absorb the full thermal growth of the offset leg, the other long leg may be controlled to permit longitudinal movement only. The guides shown at the ends of the long pipe system near the elbows are intended to maintain the plane of the pipe system only and must allow for the bending deflection of the long piping leg. When calculating guide clearances, consideration shall be given to the fact that the thermal expansion of the offset piping leg containing the expansion joint will be partially offset by the reduction in length resulting from the displacement of the center pipe system. The lateral defect may be ignored only when the distance between the hinge pin is very large and the lateral displacement is small. 3 hinge system. 2 and tatlo. In this case, the entire deflection is absorbed by the expansion joint and negligible pipe bending loads will be imposed upon the fixed point. So yan sa punto na sa kanya lahat. Where the distance between the fixed point on the left and the first hinge expansion joint C is thus a pipe guide should be installed adjacent to the expansion joint as shown. Yun. This pipe guide will minimize bending of the pipe section between expansion joint C and the left-hand fixed point, which might otherwise result from the movement required to rotate the expansion joint. One or more additional guides GN may be used to maintain the plane of the pipe system and relieve the hinges of winding forces which may be created by external load. Support for the piping system may be accomplished in various ways, utilizing available supporting structure with greatest efficiency. Now, it is essential that spring supports be used to permit the free movement of the piping between the expansion joint. Way. In system and non-90 degrees bend. So, ito. Hindi siya 90 degrees, ha? So, the figure illustrates the principle that hinge expansion joint system may also be used in other cases where there are no 90 degrees bend. Only fixed points in guns are then required. Two hinge expansion joint system. In deploying hinge expansion joint for the most effective use, tingnan nyo yung isang tangke, tapos yung pipe niya, high temperature. It should be noted that in order to function properly, the hinges do not need to be linear. So the illustration shows a two-hinge expansion joint system. In this case, the expansion joint will absorb only the differential vertical load between the vessel and the pipe bicep. Any horizontal movement due to pipe expansion, vibration, and wind load will be absorbed by the bending of the vertical pipe legs. A planar guide may be installed near the top of the vessel to protect the hinge expansion joint from the wind load at right angle to the plane of the pipe. The fixed point shown at the bottom of the riser is a fixed point only, since the pressure load is absorbed by the expansion joint hinges. So this fixed point must be capable of withstanding the forces created by the bending of the riser. Depending on the dimensions and weight of the pipe system, sufficient support may be obtained from the passage vessel and from the fixed point. If additional supports are required, spring type support should be used. So the vertical piping may be pulled to reduce bending stresses, utilizing the hinges to withstand the cold spring force. Hinge expansion joint system naman. Yan. Yung mga pangalan, pero iba naman ano. A hinge expansion joint system may be used effectively in applications involving movement under tension thermal load of piping. The figure illustrates an application of combining the thermal expansion of a piping system with the single plane movement of an item connected equipment. So figure. As long as all movement are restricted to a single plane, the behavior of the expansion joint system is quite similar to that of the system shown in the figure. So a fixed point is required at one end of the piping, while the equipment serves as a fixed point at the opposite end. The displacement of the equipment are added to those of the piping to evaluate the movement of the expansion joint. Planar guide clearances in the plane of the piping must be adequate to allow for the equipment movement as well as piping rotation. On the compact size and structural rigidity are the advantages of this expansion type. Through the use of this individual unit, it is frequently possible to compensate for the thermal expansion of irregular and complex piping configuration, which might preclude the use of other types of expansion joint. Due to the ability of the hinge structure to transmit load, piping system contain the hinge expansion joint impose minimal forces on the fixed point. Such system can be supported at virtually any point without interfering with the free movement of the system. Gimbal. So two gimbal and one hinge expansion joint in a three-dimensional system. Okay. This open-use system absorbs movement in any direction of the horizontal pipe through the use of gimbals, while the hinge angular expansion joint takes the vertical movement joint resulting from the reduction of the vertical distances between the gimbal. Two gimbals in a three-dimensional system. So nawala yung isa doon, nawala. Just a hinge expansion joint offer great advantages in a single plane application, just as hinge expansion joint offer great advantages in a single plane application. Gimbal expansion joints are designed to deliver similar benefits in multi-plane system. The gimbal expansion joint's ability to absorb angular rotation in any plane is most frequently achieved by utilizing two such units to absorb lateral deflection. An application of this type is shown in the illustration. Since the pressure loading is absorbed by the gimbal structure, fixed points only are provided. Guides are provided to restrict the movement of each piping leg. As in the case of hinge expansion joint, the location of the pipe supports is simplified by the load-carrying ability of the gimbal structure. Since in a two-gimbal system, the growth of vertical pipe length will be absorbed by bending of the longer leg. Spring support may be required on either or both of these. Guides must be designed to allow for the thermal expansion of leg contains the expansion joint and for shortening of the leg due to deflection. U-pipe, so the expansion loop. In some pipe system, the operating conditions can be quite challenging, resulting in a special consideration for the design of both pipe system and for the expansion joint. Large movement can be absorbed in numerous ways with different expansion joints. In many cases, installing two or more expansion joints together at natural or contrived offset in the system can be a good solution to absorb large movement. The same pipe system can also be used for the absorption of angular movement, which would not be possible in a straight system. Okay. Why U-bend pipe loop? So pipe loop na may expansion joint. The U-bend is a good solution for absorbing large movement. So the configuration of a pipe loop containing three angular hinge expansion joints can absorb at a minimum 3 times larger movement compared to additional pipe loop without angular expansion joint. So the hinges on expansion joint contain the pressure forces from the bellows and simultaneously ensure the movement are controlled, which help to support the pipe system. So the pipe system geometry is determined by the amount of movement to be absorbed and the rotational capability of the expansion joint. So the higher the movement, the greater the distance required between the center and expansion joint. The advantages of this U-pipe system design, we have the large movements are allowed. The stress forces on the system fixed point are much reduced compared to those from equivalent unrestrained expansion joint. Cost for fixed points are reduced. The solutions are restrained expansion joints can prove to be very cost effective, especially when the pipe system is installed at heights. The need for the substantial fixed point in guides in the pipe system that are routinely required with unrestrained expansion joint becomes unnecessary due to the pressure transport from the bellows being contained by the hinge structure on the expansion joint. So, as shown in as shown sa figure, use of expansion joint in the loop can reduce the number of loops from 3 to 1. So yeah, as shown in the figure, right side, use of expansion joints in the loops can reduce the number of loops required from 3 to 1. If, maganda dito is yung, ito. Kung wala ka nitong expansion, ano yan, tawag doon? Yung mga expansion joint, dati loop yan. So, marireduce mo yung ano. Kasi isa magpara-loop ka dyan, loop, loop, loop. So, itong isa, isang loop na to, one expansion joint is equal to one loop. So, marireduce mo siya. Okay. So, venting or draining may be required if the loop is fitted vertically. Expansion joint should be fitted as close to the elbow as possible. Guide should be close to the outer expansion joint to direct the pipe growth onto the band. So, the guide must allow free travel of the pipe system and expansion joint under all movement conditions. So, the center expansion joint in the U-bend should absorb the rotation equally to the rotation of the outer expansion band. It is advisable to cold pull the U-bend so that the expansion joints work equally from their neutral condition. This maximizes the available travel from the band, minimizes the height of the band, and halves the total deflection force applied to fixed point. So 3 hinge in plane U-bend system, where 3 hinges, large movement can be absorbed. So yan. 4 hinge angular expansion joints in U-bend pipe system. The U-shaped bend shown below is theoretically able to take infinite number of positions due to the friction in the hinges and the difference in stiffness between the expansion joint. If no guide GA is installed, and this problem can be solved by installing a lateral guide GA at the top of the band. Yeah. Okay, ito pala yun. So, the U-shape mentioned ito sa left side, able to take infinite number of position due to friction in hinges and the difference in stiffness between the expansion joint if no guide is installed. This problem can be solved by installing a lateral guide ito, at the top of the bend, pandi siya mag-rotate. Okay? Next is the pressure balance. Inline pressure balance expansion joint. The figure shows the use of an inline pressure balance expansion joint used to absorb axial moment in a long straight pipe system. By utilizing this arrangement, the two fixed points shown are relieved of pressure loading. Since the piping is relieved of compression pressure loading only, a minimum of guiding is required, primarily to direct the thermal expansion of the piping into the expansion joint in an axial direction. Pressure balance, dalawa. So yan sa gitna nagbabalance. So pressure balance expansion joint located at the change of direction. Ayan. So the figure typifies good practice in the use of pressure balance expansion joint to absorb axial pipe system expansion. Note that the expansion joint is located at a change in direction of the piping, with the elbow and at the end of the pipe system being secured by guides. Since the pressure thrust is absorbed by the expansion joint itself, and only the forces required to deflect the expansion joint are imposed on the piping, only a minimum of guiding is required. Directional guiding adjusted to the expansion joint as shown may suffice in most cases. And long, small diameter pipe system, additional guiding is necessary. So ito yung pressure balance niya. Inline pressure balance between two passage vessels. When two passage vessels are to be connected, a pressure balance expansion joint will usually provide the best solution. The solution should include absorbing the growth of interconnecting pipework, accepting movement due to any differential growth of the vessel, and catering for the effect of any settlement. The design of process vessel will often prevent any significant load from the pipework being applied to the vessel or nozzle. Through the utilization of a pressure balance expansion joint, all forces generated by internal pressure acting on the expansion joint bellows are contained by the restraining structure of the unit. This leaves the spring rate forces created by the bellows movement to be contained. In most cases, these forces are significantly less than those of the pressure forces and typically are easily resolved. The alternative to using pressure balance system would be to deploy simple unrestrained expansion joint. However, this would require the installation of a structure to enable fixed point to be included. This could create significant cost, particularly when the interconnecting pipework is at greater heights. In some applications, a simple inline axial pressure balance unit can be used. This style of expansion joint will accept mainly axial movement, but can be designed to additionally accept small lateral movements. So, and more complex arrangement, especially expansion joints, are required with a twin bellow incorporated to accept greater lateral movement. Pressure balance expansion joint located at the change of direction. So, yan. Kanina, meron din kanina, di ba? So, if a change of direction existing in a pipe system, pressure balance axial expansion bellow joints, elbow or T-type, can be used to absorb the movement without charging the fixed point of end connection with high forces resulting from the pressure tap. This is achieved by using an additional equalizing bellow subjected to the line pressure and interconnecting devices between the line bellows and equalizing bellows. Each bellow should be designed to absorb full axial movement. Opposite niya. So, nag-expand na counter. Use of a pressure balance expansion joint on a vessel. So the figure shows a common application of a pressure balance expansion joint. Under various process conditions, the vessel and the vertical pipe may expand at different rates. By installing a pressure balance expansion joint as shown, the differential vertical moment is absorbed as axial moment on the expansion joint, and the thermal expansion from the central line of the process vessel to the pipe system is absorbed as lateral deflection. The pipe system may then be secured by a fixed point at the bottom and furnished with a guide adjacent to the expansion joint. In many cases, no external structure is available at the upper elevation of the process vessel, and the guide must be connected to the vessel itself. Using this arrangement may result in some bending load upon the pipe system, especially where the vessel is tall and is subject to wind loading deflection or similar effect. Where the guide is attached to rigid external structure, the expansion joint must be designed to absorb wind loading deflection and other similar loading as lateral deflection. Pressure balance expansion joint on a turbine. So the figure shows a typical application of a pressure balance expansion joint for a combined axial moment and lateral deflection. Both the fixed point at the end of pipe system and that of the turbine ensures that only guides are required. With an effective design, the guide can be made directly above the turbine to absorb the axial moment forces of the expansion joint without imposing this on the turbine. The only force imposing on the turbine is required to deflect the expansion joint laterally. Pressure balance joint on the turbine. Again, so the figure shows another turbine application, but in this case, the fixed point of the turbine is located at some distance from the expansion joint. The expansion of the turbine between its fixed point and the expansion joint is observed as lateral deflection. A fixed point is used at the center fitting of the expansion joint. Since the expansion joint is located close to the turbine, guiding is not required between the turbine and expansion joint.